students, welcome to the CBSE Chemistry lecture series. In the last class we discussed the colligative properties of in solution chapter and the important property lowering of vapor pressure. So today in this session we are going to discuss about the second colligative property, elevation in boiling point. First of all, we have to know what is meant by boiling point or define boiling point. The boiling point of a solution is the temperature at which the vapor pressure of the liquid becomes equal to the atmospheric pressure. That is called boiling point of a solution. So here in this property, colligative property, we are going to compare the boiling point of solution as well as the pure solvent. Say for example, you can take a drinking water. Drinking water, as all know that the boiling point of drinking water is 100 degrees centigrade. If we express in what Kelvin scale, it's a 273 Kelvin plus 100. So totally 373 Kelvin. Suppose if it is a salt water or sea water, what happened to the boiling point of a sea water? It will be slightly increased, say for example 101 degree centigrade or something else. So the difference is what? Delta T. Here this is a pure solvent P naught. This is solution T. We can use the letter T. So the difference is what? Delta T. So if we represent in a graphical representation, temperature increases in this x-axis and the vapor pressure increases in the y-axis, and this is called atmospheric pressure. Atmospheric pressure, correct? Suppose if you have pure solvent, I already told you the boiling point is what? When the vapor pressure of the liquid touches the atmospheric pressure, that temperature you have to note down, that is called what? T naught. So this is a graph A and B. This is for what? Pure solvent. Suppose if it is a solution, or you can say sea water or salt containing water, it touches the atmospheric pressure which is slightly higher than that one. That we can call as T. And the difference between these two we can call as delta T. So this is a boiling point, you have to put the suffix B, delta TB. Now you have to see that one, why there is an increase in the solution cases. So we have to think about, if it is a pure solvent, only the solvent molecule is there. If it is a salt is added or non-volatile solute, say for example the seawater a lot of containing salts, there is an interaction between the salt and the solvent molecules. The temperature is slightly increased, that is delta TB. Yes, the delta TB there is nothing but T minus T naught. The T is always greater than T naught. The T naught represents pure solvent. T naught means pure solvent and the T means solution. When we express the boiling point, so the delta TB is directly proportional to the molality of the solution. What is the molality of the solutions? Delta TB is proportional to, say you put on constant, that is called K. We put a suffix B. This is for ebullioscopic constant. Where Kb is known as ebullioscopic constant. Ebullioscopic constant or molar elevation constant. Molar elevation constant. Where the molality is defined as, already we defined normality, molarity, everything we have defined. So we have nothing but what? Molality is defined as, it is nothing but number of moles of solute present in 1 kilogram of a solvent. That is W2 by M2. That is called number of moles of solute into if the solvent is expressed in what? 1 kilogram of solvent. So you have to put 1000 divided by W1 grams. So this is a formula for molality. So delta TB, you substitute the formula, delta TB is what? Kb into W2 by M2 into 1000 by W1. Normally in this particular elevation in boiling point, they will ask you to calculate the molar mass of a solute. So you want to interchange places. M2 if you want to find out, then you have to say Kb W2 into 1000 divided by delta TB into W1. This is the formula for calculating molecular mass of a solute. Here you have to know all these terms. What is W2? That is mass of solute. Now what is W1? Mass of solvent. Now what is M2? Molecular mass or molar mass of a solute. And what is Kb? It is a molar elevation constant. Molar elevation constant or ebullioscopic constant. The delta TB is nothing but T minus T naught, or difference in the pure solvent and the solutions. That's all. If you know all these things, we can find out molar mass of a solute. Yes, we will take examples or application part. We will take a problem, NCERT problem. The boiling point of benzene is 353.23 Kelvin when 1.80 gram of a non-volatile solute was dissolved in 90 gram of benzene. The boiling point is raised to 354.11 Kelvin. Calculate the molar mass of solute, where Kb value is given as 2.53 or benzene is given Kelvin kilogram per mole. So what are the data available first? Given data you got right. What is W2 is given? How much? Is nothing but 1.80 gram. What is W1 is also given as 90 gram. Then what is, and T and T naught is given. Okay, that is delta TB you have to find out. T minus T naught. T is given as what? Is this case 354.11 minus 353.23 Kelvin. Find out the differences. If it comes out 0.88 Kelvin. Kb is also given in the problems. Kb is also what? 2.53 Kelvin kilogram per mole. The data is available like this. So the calculate the molar mass of solute. You want to use the formula directly. M2 is equal to, okay, W2 into Kb into 1000 divided by delta TB into W1. Substitute the values. W2 is given as a 1.80. Kb is given 2.53 into 1000 divided by delta TB is what? 0.88 into W1 is a 90. If we simplify all these things, we can get the value of 58 gram per mole. That is the molar mass of the solute. So direct substitutions, we can easily find out. Another one problem, NCERT in-text questions. Boiling point of water at 750 mm mercury is 96.63 degrees centigrade. How much sucrose is to be added to 500 gram of water such that it boils at 100 degrees centigrade? Kb is given as 0.52 Kelvin kilogram per mole. These are the data available and ask you to calculate what? How much sucrose, that is W2 is the question mark. So sucrose is a solute here. So you have to write all the data, first given data. W2 is equal to question mark, correct? What other data are given here? W1 is given, how much? W1 is 500 grams. And the boiling point of what? Water at 70 is what? 96.63. Whereas at 100 degrees centigrade, what will be the things they are asking the questions. Yes, W2 is a question mark, whereas the W1 is what? 500 grams. Then molar mass of solvent, that is 18. Molar mass of solute is given, that is a, yes, sucrose they are given. Sucrose formula C12H22O11. So you got to add all these things. That is what? 12 into 12. Atomic mass of carbon is 12. So 12 carbon atoms into 11 into 1 plus 11 into 22. 22 into 1 and 11 into 16. If you add all these things, it will comes about 342 gram per mole. That is a molar mass of solute sucrose. So what other things is given? Delta TB is also given. Delta TB is what? So in this particular case, 100 minus 96.63, which is equal to 3.37 degrees centigrade. That is the difference. That is the difference is there. We can use the formula straight away. M2 is equal to W2 into KB into 1000 by W1 into delta TB. Substitute the values here. W2 only you got to find out. So you got to cross multiplications. W2 is equal to M2 into W1 into delta TB divided by KB into 1000. What is M2 is given? That is 342 into W1 is given 500 into 1000. Sorry, delta TB is given as what? 3.37 divided by what is the KB value? 0.52 into 1000. Yes, if you solve all these things, we can get the value of 1108.2 grams. That is a mass of solute, mass of sucrose. Thank you, students. If you have any doubt, please mention in the comment box. I will clarify your doubts. Thank you, students.